Liam back, everyone. We were just arguing about if your teeth were in your gums or if your gums are in your teeth. But anyways, welcome everyone to Critical Mass, a show coming out of the Black Hammer Organization SciTech Committee, where we break down scientific topics with an anti-colonial revolutionary analysis. I'm Chief Sa. I am the International Chief of Science and Technology. I represent Korea. I use they, them pronouns.
I am Chief Felix. I'm the International Chief of Staff of SciTech. I rep Africa, and I use they, them pronouns.
And we have a very special guest today. Go ahead, Comrade.
Welcome back, everyone. I am Comrade Rohan, representing the nation of Aboriginal Australia, using he, him, and Z0 pronouns. And I am within the SciTech office doing all different sorts of things. And with those all different sorts of things, one thing I want to talk about, I have like a little story for you guys just to get us into this. So there was a string and it walks into a bar. And the bartender says, "I'm sorry, we don't serve strings here." Okay, that's fine. So the string walks out, ruffles his shirt a little bit, and then he comes back in. And then the bartender says, "Weren't you just the string that was in here?" And then it says, "I'm afraid not." So with that, I'm going to string you along into our topic, which is string theory. So what string theory is, just a little introduction slightly on what string theory is. String theory is basically a way to see the universe, but in like a different way. It's a new way of seeing the universe. Instead of seeing the universe as tiny little particles, we see them as strings. And this is what string theory is.
All right. I'm pretty sure we have a video, is that right? Of string theory and getting into that a little bit more. Thank you for that incredible introduction, Comrade Rohan.
From structures of molecules made up of countless, even smaller things, atoms. We thought they were the final layer of reality until we smashed them together really hard and discovered things that can't be divided anymore, elementary particles. But now we had a problem. They're so small that we could no longer look at them. Think about it. What is seeing? To see something, we need light, an electromagnetic wave. This wave hits the surface of the thing and gets reflected back from it into your eye. The wave carries information from the object that your brain uses to create an image. So you can't see something without somehow interacting with it. Seeing is touching, an active process, not a passive one. This is not a problem with most things. But particles are very, very, very small. So small that the electromagnetic waves we use to see are too big to touch them. Visible light just passes over them. We can try to solve this by creating electromagnetic waves with more and much smaller wavelengths. But in quantum physics, shorter wavelengths means more energy. So when we touch a particle with a wave that has a lot of energy, it gets a kick. By looking at a particle, we change it. In quantum physics, we cannot know where a particle is and where it's going with absolute precision. This fact is so important that it has a name, the Heisenberg uncertainty principle, the basis of all quantum physics. So what does a particle look like then? What is its nature? We don't know. If we look really hard, we can see a blurry sphere of influence, but not the particles themselves. We just know they exist. But if that's the case, how can we do any science with them?
All right, I'm back. I really like that video. I think it's a really nice introduction to these super, super small particles that we're going to be talking about and modeling with strings. And really just like what seeing these particles are and like these problems that kind of come about and why we have to use strings and string theory to kind of get into this. But what were y'all thinking, Comrade Rohan, Chief Sa, watching this video?
All right. He's the best, first of all. Chief Mace says so.
Thank you, Chief Mace. But yeah, so this video is actually really, really good. It's a fantastic little introduction to at least explain the basis of string theory. So I'm sure you guys have heard, and I'm sure many of you are possibly intimidated just by string theory in general, because a lot of people say oh, it's so complicated, it's so difficult. In fact, in school, I was advised against looking at string theory just because it was it's too hard. You're probably not going to be able to grasp it. And because I have a very rebellious nature, I did it anyways. And now I'm here. So in regards to string theory, yeah, it's basically what it says. What does a particle look like? Well, we can see them as dots, like what we used to think they were with, you got your theory of relativity up in there. But if you really think about it, an easier way to perceive it, and one that makes a little bit more sense, is the fact that we see the universe as strings, or at least, yeah, that's what makes up everything, just tiny little strings. And I kind of like how that video explained it. And it's really not as complicated as people want to make it out to be. It's just the fact that, if you were to try to look at different sources on string theory, you're going to find a lot of different things. You're going to find a lot of math. But another thing that you're going to find is articles that are blocked unless you pay for it. So that actually shows you one thing. That kind of shows that, hey, maybe it's not as difficult, but a certain someone is probably blocking us from actually being able to view it properly. So here, you're going to get that knowledge that's probably blocked out.
That is true.
Be thankful. But yeah, so what were your thoughts on it?
I think it's interesting because, right, the premise of it is things that are so small you can't perceive them because either A, they're too small for the physiology, meaning how your body is set up is too small for your eyes and your brain to work together to actually perceive it. But also there's the idea in science that by merely observing something, you change its nature. Therefore, you cannot observe it in its natural state because you, in the act of observing it, are changing its whole deal. You feel me? So I think that's interesting because it's not only something that happens on the tiny little micro scale, meaning teeny, and we're actually on the nano scale because I'm pretty sure they're talking about quarks and stuff.
Oh yeah, quarks were up there.
But you can actually perceive this on the macro scale, and in science, macro scale means stuff that's big enough for you to see with your naked eye or
that's where you get your theory of relativity.
Exactly, and even the way it was explained to me is, so imagine you're measuring the temperature of something. You take a thermometer and you put it in, let's say you're measuring the temperature of a liquid. You take a thermometer, you put it in liquid so it can tell you what temperature it is. But even by the act of putting the thermometer into the liquid, you're changing the liquid's temperature because even if it's just a tiny bit, the temperature of the thermometer itself, how hot or cold the thermometer is going to affect the temperature of the liquid because, heat transfers to try to equalize itself out. That's just the law of thermodynamics. It's the law of nature that stuff wants to reach equilibrium. So if you put something hot, I'm sure you've seen it. If you put something hot and something cold, it's going to eventually even out. For temperature. So even by the act of putting the thermometer in the liquid, trying to see how hot or cold it is, you're changing how hot or cold it is. So I believe that it happens on a tiny scale because we know it happens on a big scale.
Oh yeah, for sure. And I actually really, really love that analogy that you made about the temperature because I'm actually going to call back to that later on when we start talking about the Heisenberg uncertainty principle because there are some examples that actually come into play with that exact story that you just laid out. So nice job. I hope y'all remember that. There was a question that I saw that come down, and we can take a look at that and just, yeah. So Tiger said, do you think about 5 or 6 years, everything you know about string theory will be completely different? Me personally, oh, for sure. Just because string theory right now is constantly changing. That and the fact that there are already people that are like, string theory may not be it, but then they take a closer look and they're like, maybe it is it. And the further you go into string theory, you get into another theory called M theory, which we're not going to talk about because that's a whole other show. And I'm going to confuse y'all, I'm sure I will, because that's definitely a big theory. But it can definitely change and manifest and become a new theory or just a new way of thinking about it. Because for the longest time, weren't we all thinking that the theory of relativity is where it's at? Well, now it's string theory. So
what if there's another one called rope theory? That's all the strings in a string making into a rope theory.
I'd be afraid of that.
Well,
yeah. I was going to say, be careful what you wish for, Chief. So there is something called knot theory, and it is absolutely disgusting.
Yep. It's not knocking on our door.
Oh my God.
All right, what is this question? I'm going to see, what are some uses for understanding strengthening, how it will help humanity? That's an interesting question that maybe we'll hold on to for a little bit as we continue to talk about it. That's, very large question. But I think, I kind of want to bring it back to string theory. I'm not sure how it will strengthen humanity. String theory is supposed to be like the theory of everything, is what people say. But we can't understand everything unless we understand, these smaller subatomic particles, which is what these strings are trying to model. I think about still atomic bombs and stuff, how so many people thought that they couldn't even split atoms. And then people were like, oh my God, we can go even smaller than atoms. And those are the units that we are trying to model with strings. We are trying to model atoms, truly the unbreakable, smallest things things ever. And like atoms too are also very, very, very hard to perceive. But these incredibly small things that, you know, some problems come up, but it's these units that make up like theoretical physics. They have all sorts of funky little names. We'll talk about one of them a little later. But yeah, I think it's really cool that we can do this with strings. And what is this question? I want to read it. Chief May, is string theory the unifying theory? That's a really good question. And that's a question a lot of people are trying to answer. Maybe some of our colonized brilliance can help answer that question, because I'm sure we can figure it out in a little bit. But it could be, if we can help, you know, figure out some of the questions that string theory still is trying to answer. Yeah. What do y'all think? These small particles. I think they're pretty cool. I didn't know I knew they existed, but modeling them with strings, bold move.
You're right. Oh, you're definitely right. So that's the funny thing, because we all think, you know, all right, smallest particle, atom. You try to split an atom, boom, you can't get any smaller than an atom. But then string theory tells us, but what if we tried? String theory asks that, but what if we did this? And what if we did that? You think atom, and then so you try and go smaller and smaller and smaller, and oh, look, you have strings. And then you have different dimensions that go around that string. And then you start realizing maybe there are other worlds out there, kind of tying back to our whole parallel universe dealio that we had last time. And as for if it's the unifying theory, well, I mean, if it was the unifying theory, it would be called a theory. But in regards to that, I can't say with utmost confidence that it would be the unifying theory, just mainly because science is constantly changing. And string theory, of course, is still not set in stone. There's a reason it's called a theory. It's not exact. It's constantly changing. And there's always something new that's going to come out that's going to, you know, change the way we think about things. So perhaps something could develop from string theory that could perhaps be the defining theory of the universe. But right now, we're just going to have to stay tuned and let colonized brilliance take the wheel for this one.
Liam back, and I see a question from Coach K. Liam back, Coach K, and he said, what do we believe string theory helps us understand better? This is gonna sound like a cop-out, but I'm being 100% genuine. I think it lets us know that we don't understand as much as we thought we did, that the base level perception of the world is a certain type of people tend to teach it, has as its base of assumption that we understand everything about the world, and we can just move off that assumption, and everything else we learn and discuss is based on that. Whereas string theory challenges the idea that we even know what we or the rest of the world are made of. I mean, if you don't know what the smallest constituent or smallest part of something is, then how can you realistically claim to even understand what the thing itself is? Like, if I didn't know I had a heart in me, how would I say that I understood the human body? I think it's just this thing where it forces scientists to admit that they don't really know what is going on. And that can be a scary thing, but I think for the colonized masses, it's a beautiful thing. Just because we have such a long, beautiful, rich history of being at the forefront of scientific discoveries, of doing things like divining the stars, interpreting the heavens, inventing the ships, building the pyramids. And I think that for us, it's just another adventure within like scientific discovery. So if you want to make adventures in scientific discovery, I'm thinking, you know, one of our next subcommittees I'm looking to make Inside Tech as an education one. And I want to have, you know, people that spend time reading these papers, figuring it out, and figuring out how it does relate to the colonized masses.
For sure, for sure. I really like that. That's a whole lot of really good points right there. And yeah, it is a theory, and it is, you know, that whole uncertainty, and it just shows, you know, we don't really know. But at the same time, isn't that exciting? Isn't it exciting to hear, oh, shoot, there's undiscovered riches. There's some new things that we can find out. And, you know, it's like whenever I hear of something that's uncertain or I'm just not sure, whenever I say I'm not sure, the first thing I do is research, because it makes me so excited to learn something new, or to at least learn, like, even though I can't get all the way, I mean, there's a limit, or at least like, even though I can't get all the way into actually knowing what it is, I get closer and closer, and there's always more to discover. That means work never stops. And that's kind of like, that was like my thoughts throughout that whole thing.
Oh yeah, absolutely. And like just being able to dive into science that like we don't understand, it's just so much fun. Colonized people have so much fun doing science. And then like we're able to find the answers because we are the ones who are actually able to understand this stuff and figure out if string theory can be the unifying theory or not. Really push this a little bit farther and push it farther by joining Black Hammer and joining SciTech, because where else are you going to be pushing it? But pushing these units, being able to better understand, these fundamental units, and it's like, what are these fundamental units even supposed to be doing? I mean, we're talking about these units that are so small, but they are still modeling these things in our real world, which is why we need to understand them. There are these fundamental units that make up matter. There are fundamental units they're trying to, maybe we'll talk about it a little later. Hopefully it'll make up gravity, dark matter. Everything that's in the universe is made up of these super, super, super small particles. And once we understand that and start applying it to everything that is made up of these small things, there's really no stopping like what string theory or what colonized people can do, with a theory like this. Yeah, all right, so we gotta, let's see, how are y'all feeling? So fundamental units, super, super small stuff, super string theory. I think that's coming up next.
Oh yeah, it sure is. It sure is. I'm super excited for super strings.
Super strings and super string theory too. I mean, I feel like it sounds cool being called super string theory, but it's really just adding an additional layer that helps us better understand what these small units are doing and actually like taking into account mass a little bit, because we're dealing with, like I said, they're so small we can't even see them, but it's also really hard to like measure them, but they do still have like a super, super small weight to them. And that's what super string theory is attempting to capture, that it's not just these strings, that there's mass on these strings, that we need to talk about. So I believe we have a video for this. Is that right? That we can pull up?
Yes, we do. We got the fermions on strings.
Yes, we do. I didn't see it.
Specific type of onion.
It's like whenever an onion sits out and it gets too old, it's been fermented. Yeah, fermion.
It's got fur on it. It's an onion that's a furry.
To include fermions in our model, the idea is to add spinors on the strings. They are the mathematical ingredient that already described fermions in the standard model. By simply adding spinors to the strings, we solve two problems. The model now predicts the existence of fermions, and it no longer predicts the tachyon, the particle that was problematic. This more complete theory is called superstring theory.
All right. I really like that video. I feel like it's really simple. And fermions also are just the super, super small units that make up mass. And of course, we are still trying to model it after real life. And sometimes when you do that, weird things come up. That's where the tachyon came up, or whatever it's called, because they started doing some calculations. They're like, this is a weird thing that we don't see in real life. So we got to make some changes, add on the fermions to these. And then we start to do these calculations, and it's starting to model the real world, because the real world has mass. Like I said, we're working with really strong, really, really small units, and we need to kind of account for that a little bit. Yeah, I'm loving the super string theory with the arms. That's how I feel too when I was learning about it and talking about it with Comrade Rohan. But what are y'all thinking? Fermions on strings, super string theory? I mean, I think it's pretty strong. I see this question. Maybe we can answer this. What the bleep do we know? I actually don't know that movie.
Yeah, no, I don't know that one, but if you could explain it, I would be like, I'd love to comment on whatever that movie could possibly be about if we got a brief synopsis. But anyways, like regarding fermions. So yeah, if you take a fermion and it becomes, like extra sharp, then you get a tachyon because it's a tach.
I never know, because see, I don't understand it either. I'm learning this like sort of as we go. So I never know when he's serious or not until the end of it. And I'm like, okay, that makes sense.
That's fair. That's fair.
I like that hashtag that we just had, a free tachyon. Can we get that moving?
Oh yeah,
tachyon.
Oh yeah, everyone right now. I just want to see some hashtag
free tachyon. Yeah. Remember, he did nothing wrong. Maybe he does exist. That's the thing we don't know. That's what I took from this is all modeling. I saw a tweet that was like, scientists is literally F around and find out. And this is literally exactly that. They're like effing around modeling stuff. They're like, is this going to do what the real world does? we don't know. Like, let's just try it. And that's why they said it was existed. Then now it doesn't exist. Now maybe we're actually modeling fermions. It's really just a constant process of like doing stuff and seeing if it is working or not.
Yeah, but even then, like, there's absolutely nothing wrong with not knowing something. That just shows that, you know, some other people, whenever they notice that they can't do something, they're like, okay, it just doesn't exist. Let's just take that all out. You know, it is. You're feeding into that cancel culture, and I just don't agree with it. I don't see what can you possibly gain by taking it out. It's like those books of the Bible that you took, that, you know, people took out, and now all of a sudden we're trying to relearn what the Bible means. Now we got to relearn what other stuff means because people want to keep taking it out. Perhaps there was something that y'all couldn't reach, but we could, and we still can, you know. So yeah, free tachyon. Put tachyon back in schools. We want to put prayer back in schools so bad. Let's put tachyon back in schools. Yes, let's free that tachyon. That's exactly what I want to see.
And I think the colony teaches us we should be scared about what we don't know, because the colony teaches us to never delve deep and overturn contradictions, but only to be, well, scared. Like, I remember that in a rally I was talking about how Europeans, like the concept of zero sort of broke down their entire society because they were scared of it. Like, actually, the end of the Dark Ages for Europeans and the beginning of their so-called enlightened Renaissance was when they finally accepted that zero existed and was a thing. And I think that shows so deeply like a certain type of people's fear of the unknown, what prevents them from making scientific progress. Like, imagine if I'm like, I have one water bottle, now I have no water bottles, and everyone was like freaking out, like, oh my god, there is no water bottles. How many water bottles is that? Holy crap. Like, it's just a fear of the unknown.
Yeah, but I mean, there's nothing wrong, as we've seen from Frozen 2, going into the unknown. There's absolutely nothing wrong with that. You know, you're just diving into something that you haven't seen before, and undiscovered territory can be exciting, as I explained earlier.
And in our work that we do as a revolutionary organization, being able to understand that we never seek out the unknown alone, that we always are applying our brilliance as colonized people through a collective, is so beautiful. Because I've been in meetings where someone has an idea and I'm like, I would have never thought of that in a million years. That is so clearly, like, obviously what we need to do. I just would have never thought of it. And yeah, so definitely, especially as it relates to science, that collective brilliance, I feel like the way science is done in the colony is one person in a lab or in an office or, you know, in a room alone, crunching numbers day and night, or like in a, like, working with, you know, cells day and night completely alone. Like, people are not meant to do science like that. That's not how science is meant to be done. Which is why Black Hammer is so important. And anyone who's watching this that is interested in science, that wants to do science, I really urge you to hit us up. Our email's right down there, bho@protonmail.com. I feel official. I feel like a YouTube influencer. But email us. Like, you don't have to have any background. Like, a lot of us didn't have any background. Like, I don't know how to build water filters. If you told me that I was going to be leading building water filters, I would have been like,
it'd be unbelievable.
It
would be unknown.
Yeah.
You'd be venturing into the unknown. Yeah. That's what we're doing this whole time.
Comrade, you want to talk a little bit about SciTech?
Well, SciTech was very interesting. First of all, it was my first. This was my first leadership, and SciTech was like my first whole thing. And like, it actually made me feel really, really good, because I was told not to study science in school. They told me they wouldn't give me my degree. I was told I wouldn't be able to do this, couldn't do that, couldn't study biology, couldn't go on with microbiology like I thought I could. And so, like, I was definitely down in the dumps for that. I mean, I ended up studying math, which isn't bad. Like, I love math. But what hurt is the fact that I couldn't be in a lab setting like I really wanted to, because I love science so dearly. The only issue was, like, you know, they just wouldn't let me study it. But now, here, I'm using my science knowledge that I still have, because I still took the classes. And I'm using, like, the science knowledge that I have to do all these other things that I never thought I could do. No, I never thought I could build a water filter, never thought I could be involved in that project. I know I'm good at research, so I thought the only thing I'd be good at is just looking up stuff. But no, like, I can actually do a whole lot more. And, like, even being in IT, like, I can do technology. I can inform you on your technological needs. And it's just so amazing. And it's so gratifying to be able to serve the people in that kind of way and use it for colonized people, using colonized brilliance for colonized people, just the way it should be. And that's what I like.
He's a genius, y'all. Like, seriously. And he speaks like 20 million languages.
Okay, just 20
million languages.
You're adding so many zeros now. You must really not be afraid of zeros anymore. Look, we've gotten over our fear of zeros.
I was never scared. We were in age of setting off fireworks. But anyways, y'all, I think that's a great segue, you know, because what we're talking about is our fourth principle of unity. Seeing colonized people, understanding that we are the leadership of the revolution and we are fully capable of building a new world. So why not delve into the other two too? I'm gonna pass it off. Teachers, you want to take us through?
Yes, absolutely. So we are Black Hammer Organization, the biggest, baddest anti-colonial revolutionary organization in the game. And we are made up of poor and working class colonized people united under 4 principles of unity. Number 1, we believe the colonized proletariat should have dictatorship over our lives, labor, land, and resources. Number 2, we believe all colonized proletariat are equal, no matter gender, sexuality, age, skin tone, body type, location, religion, language, mental/physical differences, and/or bi/multiracial identity. Number 3, we believe all the problems the colonized face are from colonialism and the submissive neocolonialists that are within our colonized nations. And number 4, we believe that the colonized proletariat is the only true proletariat. Only through our leadership can white power, capitalism, colonialism, and imperialism and all of its symptomatic offsprings be smashed. And that is exactly what we are building here at Black Hammer and what you should help us build. So we are fundraising right now for SciTech. It's up on the slide. We have a Cash App. I want to see some donations rolling in. Our goal today is $350. You can donate via Cash App, BHO SciTech. But I want to hear from Chief Comrade Rohan, how you're feeling about being in SciTech. I know Comrade Rohan is already talking a little bit, but you want to talk about IT since that's on the screen a little bit?
Yeah, sure. IT is super crazy fun. I enjoy it a lot because one thing that I tried to do again in school was like do IT. There was a work study job opportunity that I had where I could do IT, and it was run by a colonized person. So I was thinking, all right, bet I'm going to try and do it. No, they didn't let me do it. They were like, you may be overqualified. Isn't that a good thing? Because the school's Wi-Fi is so bad. It's like, it's not even Wi-Fi anymore. It's divorce-fi at this point. Like, it's absolutely awful. And I'm sure I could have done more about that. I've helped more people on campus with their technological needs than the actual school has itself. And I also did computer programming in school just because it was part of my major, and I also found it fun. So I kept doing like a bunch of things like that, but they wouldn't let me go any further with programming because again, it's like they saw me and they were like, this one will be too powerful. We can't let him be too powerful. And so now here I am, like I taught myself multiple different programming languages, starting with Visual Basic. And even just using Visual Basic, I designed a really super cool program that makes it easier to buy Broadway tickets. That is what I designed. That is what I coded and came up with. They did not go forward with it because like they just claimed that there were some problems with it or that certain things went wrong. I don't know. At first I was complimented and then it was just like, maybe not this. And then I was given a B on the project and they were just like, good job next time. I'm like, next time? I literally, like, I showed this to someone who doesn't even, like, you know, do Broadway. And even then they were looking at it like, oh, shoot, this is real. And so, you know, that just shows that, yeah, we are silenced a lot of the time. But you don't have to be silent anymore with IT. So, yeah, definitely join IT and join SciTech. And, yeah, I want to see some donations.
Got $10. What are them reparations? You know the deal. Open those purses. You're on stolen land. We're building a revolution. You know the deal. All right. I see Reset and Executive. We got $50 combined. Thank y'all so much. Non-colonized people, check out our reparations core for sure. Chief Ama's got $5 on it. Salute to Chief Ama. We got Airplane from the reparation core too. $40 in reparations. These are going towards us building up IT self-determination for our people, for our organization to usher in the revolution. So we don't have to rely on people like Mark Zuckerberg, who is an alien, like a real actual like lizard person, or you know, people like you know, Microsoft, Bill Gates. We don't have to depend on them to know that our information is secure. We're also starting a coding academy. So to give self-determination, they're so expensive. Like just like you said, they try to keep you out of coding. They try to keep colonized people from being able to code at all. Because they know, just like they knew with you, the power. Just like T. Cola said, they recognize the power to do anything to defer us. They don't even want to hand us the tools that we need because they know exactly what we're going to use it for. I see Comrade G donated $10. Salute, Comrade G, our badass SciTech secretary. Let me get some more coming in. You know, we're still working on our water project. I see $15 from Reparations Corps, Comrade 11. We're still working on those prototypes. We actually finished up our prototype. And now we're looking at a 3D printer. We just need to pressurize that tank. We're looking at, you know, I'm sure y'all remember you saw those little part that was a cardboard. That shouldn't be cardboard. Exactly. We're looking at 3D printing that part. We actually just got the 3D printer set up downstairs. You'll probably see that at the next rally. $10 from Chief Oju. Salute to Chief Oju. Who else, y'all? Who else? Chief Nenufar got $5. Salute. This is also going to be going into the optimization of the filtration system. We need some money for that because we got to have the you know, 3D printers don't 3D print air. They 3D print filament, and the filament is expensive. Open those purses, fill up that that donation jar for those filaments because it's not cheap. But we know it'll be paid back to us 10 million fold in the liberation of our people and our Mother Earth. So I want to see a little bit more donations. I want to see a lot more donations, actually. What else we got, y'all? What else we got?
I mean, I definitely want to see some more filaments because right now with this 3D printer, I'm in love so far with this 3D printer. And the thing is, like, we have a decent amount of filament already, but you really never know how much filament you're using until you actually print something. And so, like,
he said, I'm in love with the printer.
I'm in love with the filament. Oh, yeah. Oh, yeah. Fill up our wallet so we can get some filament. And yeah, there are actually many different types of filaments that you can get. Like there's like glow in the dark stuff.
Oh, I didn't know they had glow in the dark.
Yeah, they do have glow in the dark. They have like some translucent glow in the dark ones that are really cool. And then different filaments can give you different things. So we can make like, you know, stronger water things with stronger filament. So yeah, just keep them.
The amount that you donate is directly correlated to the quality of the filters we're giving out to the masses. Like seriously, y'all. Like we don't have any big donors. We don't have any like Wall Street backers. We don't have any like multi-million-dollar corporations and nonprofits like filling up our pockets so it's easy going. Salute. Thank you so much, Chief Cola. $7. Literally what we can do depends on how much y'all give us, how much y'all believe in the colonized masses to do a science that will save the world, liberate the colonized people, liberate the masses, liberate Mother Earth. Like we can only do how much y'all trust us to do, and we can only do what we can pay for. Like we have to be honest, we're building a new world where capitalism, you know, one of the symbols of colonialism is not a thing. We got to be realistic, dialectical materialists. That's not the world we live in yet. In this world, we got to do what we got to do. And I know we can do it because we raised we hit our 100K milestone for Hammer City. You telling me we can't raise $350 in a live?
Oh, I'm sure we can. I know we can. Reparation always show out. So y'all, come on, don't stop with the reparations. Oh,
Chief Oju, thank you so much, Chief Oju. We got $10 more.
And like any amount is fine. Like, you know, Subway up here singing $5 foot long. Well, how about $5 reparation?
How about you let me hold a Virgil?
Little dude from across the street. Let me hold $1.
We are the Vanguard.
Like yes, we are.
Can I get a hashtag Vanguard purse in the comments for the Vanguard purse, the purse of the Vanguard?
Everyone open up your Vanguard wallets, your Vanguard purse. Yes, hashtag donate to that Vanguard purse.
Your Vanguard money clip. Do people still have money clips?
What's a money clip?
I don't think so.
Money clips? Oh. I'm old.
I'm not from here, you know. So
you know what? I was talking today. Me and Chief Day were like, "Is Thirsty Thursday still a thing?" Apparently, it's not. We're just old.
So I mean, we are thirsty though. Thirsty. We're
thirsty for them
thirsty
donations.
Vanguard.
Thirsty for them donations and those reparations.
Oh yeah.
I want to see some more. I want to see some more. We
got
$5 from Chief Nopal. Also, y'all, any amount that y'all donate, I've donated $1 to build Hammer City before. And you know what? Without that $1, we would not have raised 100K. We would have raised 999
$1,999.
So $1 works for us. Anything you got, we'll take it. Money clips are a thing.
All right, thank
Vindication.
you, Amalicia. Money clips are indeed a thing. Hashtag don't forget about the money clips.
That's too long.
Hashtag money clips matter. All right. Thank you all for those donations. We will try and get that calculated up as soon as we can. We're going to go ahead and move it now. We are going to talk about why exactly strings are useful. We have a little video to show you guys on why strings are useful. You know, they're more than for just, keeping your shoes tied or for tucking them in your shoes when you either can't tie shoes or are too lazy to do that. Not pointing anyone out. Anyways, so yeah, let's go ahead and pull up that video about strings and their usefulness.
To understand, let's imagine an ant walking on a straw. The straw has 2 dimensions. The ant can walk back and forth and left to right around the circumference of the straw. But if we zoom out enough, we only notice one of the 2 dimensions. The second one that curls around the straw is very small and cannot be seen on this scale. In string theory, we can assume a similar phenomenon.
All right, so the similar phenomena that we can assume with strings is again working in, oh, thank you so much, GPT, another $10, all right, and another 16 in reparations. I want to see them keep coming in as we're doing this. So string theories, as we were looking at those fundamental units that came up for a second, we were talking about free tachyon, there's a whole bunch of different fundamental units in physics, and technically each fundamental unit gets a dimension. There's a whole bunch of dimensions in string theory, then you got to force it to work in our dimensions. But just like the ant, talking about if we zoom in on the ant, we can see that you can go around it, but if you zoom out, you might be like, oh, I just think this is a flat line. That is what is trying to be modeled with string theory and all of these fundamental units, is that all of these strings exist in like these super, super small dimensions, so small that we can't even see, but they do still apply to our current world because we're large. And like from our perspective, it's not really a dimension that we exist in, but it is a dimension that perhaps, if string theory proves to be useful, that these smaller fundamental units exist in. And I think that's really interesting that these units are in like 10, however many dimensions they want to be in. I mean, I know there's M theory, like you mentioned. What were y'all thinking, Comrade Rohan? I mean, I love this dimension. I love the ants so much.
Oh yeah, the ant is fantastic. That ant is really doing its thing. The ant should join. Anyways, so yeah, I actually really like the way that it showcased that. It really shows there are so many different dimensions. Like if you think about it, the way we're looking at it, like we see the ants going up and down and going left to right, but there's, another dimension of this ant that, we're not entirely seeing. There are other, like we can see the 2D and, we can see the 3D. I mean, when it comes to like, we got the 3D printing, you got your X-axis, your Y-axis. What makes it 3D is that little Z-axis right there. There's 3 dimensions right there, but there's more. Because then you have the 4th dimension, which people consider to be time. Yeah. And so like the 4th dimension with that ant on a straw would be the ant going this way and then like disappearing and then ending up like in the beginning of the straw. Like it's teleporting from one end or another. And then like there's a little debate with the straw. Does the straw have 2 holes or 1? Think about that and then let me know your answer. But anyways, so yeah, it actually does give you that different way of looking at something. And with these multiple different dimensions that this is actually trying to tell us, that shows, maybe we do have different universes, different ways of thinking of things, different ways of seeing things, because we're constantly mentioning and constantly seeing all these new ideas come up in science all the time, especially with dimensions. And yeah, there's a lot that we don't know because there are dimensions so small we can't see. But considering the fact that they are so small, that just means there are way more out there that we can ever possibly imagine, which is where you get into M theory, which is what I'm not going to go into. But yeah, that's kind of that. Those are my thoughts on it, and that's why I find it really cool because like you think that there's one concrete way of looking at something, but not really. Like yeah, you see an ant, all right, it's just an ant, it's just going up. So what? No, it's not just going up. The ant's going up, the ant's going around, the ant is going, left and right. Like that's one way that we see the ants. And maybe the ant sees it in an entirely different way. The ant just sees itself going this way, but we see it going other ways. Different dimensions, different viewpoints. So that's why, there's no point in just being stuck in that one way of seeing something. Broaden your horizons. Be the ant. see more than the ant. I want everyone to do that. I want y'all, if y'all take away anything from this, is to be the ant. See
Hashtag be
more.
the ant.
Hashtag be the ant.
I saw someone ask in the comments what the fifth dimension is, and people argue about. There's a lot of arguing in science, by the way, just so y'all know. Like, people really argue, but a lot of people call the fifth dimension a specific dimension that tries to figure out the relationship between gravity and electromagnetism, which are typically understood to be two completely different things. And so people say the fifth dimension is them trying to like figure out their relationship to each other.
That's actually very interesting, for sure.
It's a lot of math.
No, it's so much math. And
But I think too, I feel like the way they teach math is so intentionally boring on the colony because they don't want people to know the power of math. So they make it as boring as possible so that nobody pursues it. Except for Felix, who broke all the rules, I guess.
and me.
And Rohan, and Chief Fatigue, and everyone else.
And
So yeah,
I'm bad at math. Really
it's okay though. But like even then, like something I was explaining earlier, just a little bit, is like, you know, people can have like a huge fascination with numbers, but you know, numbers don't always have to go with math because there's way more to math than just numbers. And yeah, the thing is, of course, like different types of math made you quit, but it was the way that you were looking at it because
And
it was the way you
taught
were
it.
taught. Exactly. So that's why we're saying be the ant. If you're the ant, you can do all kinds of math. Speaking of math, we're going to get into some quantum gravity.
Yes, we are. Quantum gravity is very important. And just like we were talking about a little bit ago with dimension, time is oftentimes referred to as a fourth dimension. And just like last week's episode, Comrade Rohan was talking about it, we were talking about parallel universes and gravity, special relativity, all of that stuff. Gravity still applies on these super, super small units, but there is a little bit of a problem. And we're going to talk about this problem right now with quantum gravity. So let's pull up this video and I will talk about it. So here we are. Here's the Earth existing in space-time, curving, you know, gravity and whatnot. And now we're zooming in on these super, super small units that we're trying to see. And now, instead of thinking of gravity as like this curvature that we saw, we're trying to see if it can be quantized like that picture just saw, almost like a grid, where every single intersection of that grid is a fundamentally small, unbreakable unit of gravity. And that is what we're trying to do, because typically, mathematically, that isn't how they've been thinking about gravity. And when we showed that little chart of all the different fundamental units of physics, gravity wasn't one of the things that came up. And it's like, gravity still exists. How come it doesn't come up? And it's still a model. We're trying to model things. It's an incorrect model so far. We need to figure this out. So a way to try and fix this is to try and think about this idea of quantum gravity. Can we quantize gravity? Because we have all sorts of questions and problems when we think about gravity. Because again, from last week, we know that these electrons can have superposition. They can exist in multiple places at once. We have the Heisenberg uncertainty principle we're going to talk about in a little bit later. But how can gravity work on one thing in two different places? I mean, that's like an open question, and that's kind of what broke some people down and why we kind of need to quantize gravity a little bit. Because we start to run into some problems, but we need to figure this out before we keep going so that we can understand our larger world. And so far, attempting to quantize gravity seems like something we can do. That is just this infinitely small, unbreakable unit, which is ridiculous. But what are y'all thinking?
Super cool. Super cool. Oh man, just the idea of gravity, first of all, because like, again, that kind of just changes things as you know it, but like no need to panic. It's just, you know, because I mean, people will panic. Like once you hear that what you've been taught is probably wrong, yeah, the first thing you do is panic. It's like, oh no, it doesn't exist, it's zero. No, that just gives you a new way of looking at it. It's not that you're wrong. It's just the fact that your idea has evolved. So when someone tries to say you're wrong, it's like, I'm not wrong, I'm evolved. I just found a new way of thinking at it.
Which is dialectical materialism. And dialectical materialism is what let us invent water filters. It's what let us be on the cutting edge of COVID distributing 1 million masks. It's what let us build chapters all over the entire world. So it's just, because I think it's interesting too, because people say that science is only what's conventionally thought of as science. So like engineering, building stuff with your hands, like doing stuff in a lab with cells or viruses or, you know, like DNA. But we, as like an organization and as the colonized masses, understand everything to be science, like because everything is constantly changing, and dialectical materialism itself is a science. So we should, if you want to do that type of science, like understanding that everything we do as an organization and as colonized people just trying to survive is science. Like when I had nowhere to go and I was like, I'm gonna sleep in my car, where's the best place in my car to sleep? That was science. When you have to move stuff around to pay your bill, that's science. When you have to figure out the exact way to get on the bus at the right times to get on to work on time, like that's science. It's a science that we have to do to survive. If you're ready to use science for more than just survival and use science to thrive and to build a world in which we are allowed to thrive because we're not under the constant yoke of imperialism, colonialism, capitalism, and white power literally murdering us and making life like awful if it doesn't outright kill us, then you should join SciTech. Like we all have learned from each other. None of us, even those of us who do have scientific backgrounds, we're not doing the science in the field that we have a quote unquote formal education in. And as we say over and over again, you hear us say it every week at the rally, those degrees mean nothing. Those degrees are a symbol at how far you've gotten into being molded into a servant for white power. Like that's literally it.
Yeah, exactly. Like it's sad kind of when you think about it. Like the fact that people really think that they're getting their money's worth, but really no, it's scam, really.
But this is not a scam. This is a place where you can come learn science, and more than learn science, do science. Like we had our comrade Joseph of the East. He was in the meeting. He was like, "Wow, this is my first meeting. This is the first time I've ever seen people propose science as a solution and then do it." Because at these conferences on the colony, they're like, "Hey, we can solve cancer, or we can cure cancer, or solve world hunger." By the way, all right, bye, y'all. See y'all next year at the conference. They never do it.
And then like give money to those charities that are like maybe part going to the charity and then other part paying for their next meal at Starbucks. And Starbucks is expensive, yo. So
you work there. J. Felix, what do you think? What do you think about joining SciTech?
Oh, I think it's the best thing ever. I mean, like you said, the science that we do at SciTech brings me so much unbelievable joy because everything that you do comes right back to you. You are a part of the masses, you will receive the science, and you can't do science like that on the colony. They won't let you have it. They'll take it from you. You'll do it, you'll be like, oh, this is so much fun. Yeah, and then it'll just get stolen. And it's nice to be able to willingly share ideas, talk about science, because we're all so brilliant. Colonized people are always brilliant. What does this say? The conferences, can we pull up Chief Amalich's comment one more time? The conferences, they just talk to you to do a paper that gets 2 views. And I'm thinking about that tweet where it's like, would your thesis defend you? And it's like, no, your thesis wouldn't defend you.
My dissertation would push me in front of a bus like Regina George.
Exactly. And like,
it does not exist.
Yeah, like honestly, a lot of those scientists too in those institutions probably would too to like get ahead a little bit. And that's something that isn't going to happen here at SciTech. We're actually going to use science to liberate the masses and use our collective brilliance to push science, see what it can do, because we can see what science can do, unlike the colony, because the colony isn't even interested in the science that we're interested in because they're not interested in us. So, went back, join SciTech. It's on there right now. Send us an email. Yeah, BHSSciTech@protonmail.com. I want to see some emails rolling in. And thank you. You're excellent pointers, both of you. But yeah, I mean, Chief Sa, you've had a great time in SciTech. Oh, let's read this one. Colonizer math is metaphysical and not material. That's why we have imaginary numbers in math. They could not figure out our complex equations from our ancestors and said, F it, it's imaginary. That's exactly what happened. They came up with theorems to try and solve these silly little problems. And then they were like, oh, if we use it with these theorems that we said are correct, because like we're always correct, then we're coming up with these weird things that, it's like imaginary. And now we have all sorts of problems. And it's like, what? It's like, what do you mean all sorts of problems? Like maybe go back to look at your theory or just like think differently. Like they don't even have like they can't even like think that they were the ones that were like incorrect to be like, how can we do this better? Or maybe we can expand on this a little bit more. And they just like fit their theories to like what they think is right because that's all they know how to do. They don't know how to tap into the collective brilliance like we do here at Black Hammer and at SciTech. So if you're trying to tap into that, tap into this beautiful, juicy collective brain that we have here. come on in and join us at SciTech. See Chiefs a lot. Yeah, it's a really juicy brain. Yeah, and our email's back up there, so I want to see more people join. All right. So I think, are we going back to the Heisenberg uncertainty principle? I don't know. Is that right?
Oh, I mean, yeah, that's fair.
I'm
that's
uncertain.
Fair. If y'all are a little bit lost on where we are, it's okay because we are too. And so is Heisenberg. That's why we're going into the Heisenberg uncertainty principle, which honestly, I'm super crazy excited to talk about this right now because the Heisenberg uncertainty principle really just like gets down into my brain. And the reason it gets into my brain is because it's like, it tells you it's okay to not really know. It's that one part of physics that like, yeah, it's definitely uncertain. Okay, so you think about physics and you think about things that, you know, we do know. Let's think about the concrete that we do know. We all know like gravity. We know about the person who couldn't move out of the way of a falling apple and discovered that gravity exists. So yeah, now we have gravity. Okay, yeah, 3 laws of motion. Makes sense. All right, got it. So yeah, that makes sense. We can explain motion. But there's more to that. That's why you have the uncertainty principle. There are things that we just can't quite explain. There are positions, you know, things that just don't make sense. And that's what this uncertainty principle tells us. And the equation itself, you know, is a little bit complicated. And we don't have it pulled up right now. But I will say that if you know a little bit about math and you look up the uncertainty principle, then you notice that some of the symbols in there are deltas. Deltas in math usually represent a change. Here, they're going to represent error or uncertainty. And so that's something that I actually find really cool because it talks about the fact that we can't really fully grasp the position or the momentum of a particular object at some point in time. And so another thing that I kind of want to talk about is like the uncertainty principle is everywhere, and it's really how we start understanding things. So maybe for an example, like you have a negatively charged electron, and then you have a positively charged nucleus. Well, the thing that we know, negatives and positives, they're supposed to attract. Opposites are supposed to attract. Why aren't they attracting? Well, the uncertainty principle can tell you that because like the closer it gets, the closer that, just like this cat, the closer you get to that positively charged nucleus, the closer you get to that, okay, so we know the position, or at least we're starting to know the position because we're starting to be certain on the position. That means the error, that delta is smaller. The reason that the error is smaller is because we have a general idea of the position. However, the momentum is something that we don't quite know because once we hit it, yeah, it hits or it connects, and it like the thing is, it moves. Like the momentum is what I'm sort of like trying to talk about. That momentum is something that we don't know. Because yeah, let's say that like something is right here and then I knock it. Well, it had one position and then it moved to another position, but we're uncertain of like the position that it moved to. And like, we can't really decide that. We can't figure out that, yeah, once that electron hit the nucleus, we don't really know where the nucleus ended up, and we don't really know where a whole lot of other things ended up. And so, yeah, that's why I love the uncertainty principle so much. And Oju, yes, your comment is
hilarious. Great. Futurama joke, they had a horse race, said one horse in a quantum finish won in a quantum finish, and then say, no fair, you change the outcome by measuring it. That's funny. At its core, like the Heisenberg uncertainty principle, like with the electron, is saying basically, so think about electron, which we already said is not the actual smallest, but for a long time was believed to be the smallest you could get. And it's basically saying you can't know both where it is and where it's going. You can only know one or the other. So imagine like if you asked me where I was at and where I was headed, and I'm headed to the gas station, but I'm not going to tell you where I am. You can't know that. Or I'm like, I'm, at my house, but I'm not telling you where I'm going. Like you can't know both. So you can't know a path really, or there's no like dialectical to the materialism. You can't perceive the dialectic, the change of it, because you can only know where it is or where it's going. And if you only know where it's going, you don't know where it's coming from, so you don't really know its direction.
Yeah, that was the part with the electron. Like, you know where the electron's going. You're getting its position, or at least you know where it is because it's moving. But you don't know where it's going, and you don't know where that nucleus is going either. That's the reason, yeah, that we can't quite get why they don't attract, and that's that uncertainty principle at play.
So we don't know what they're doing. They're just like...
And I will say too, the most interesting thing, cutest fact ever, and then we can move it, is that when we do try and figure out where these super, super small fundamental units are, so we attempt to measure them, like in the beginning we were talking about perceiving particles. To do that with super small particles, you hit it with a wave. Basically, to try and measure these small particles, you'd have to hit it with a wave so strong, it would create a black hole. So like this stuff is like, it's no joke. There's no way that this is possible.
I did not know that.
Yeah, a ridiculously small black hole, and like we're not doing that in a lab. So it's not something to mess around with. It's very hard to deal with these things. And I think with that, we can go on ahead and move it to a fundraising call and just let people think.
I don't know. I'm a little uncertain. Should we move on to a fundraising call? I think so.
If you don't want to open up a black hole, you better open up that purse.
Exactly.
I don't make puns unless he's like, I'm not. That's not my usual sense of humor.
Well,
All
we're
right.
uncertain. Oh my God. Yes. All right. Yep. You see our Cash App right there. Hashtag BHO SciTech. Still trying to meet that goal, everyone.
We're about halfway there, which is good because this is the second half of our fundraiser call. So I need y'all to bring that same energy from last time into this. Seriously, all these projects go directly to the masses. They go directly to the people. They go directly to us, not making a black hole in the lab because we would all die. But they do go to us building the liberation for our people. And yeah, and I think that's interesting too because a lot of time colonizer scientists just want to play God, I think, which is
yeah.
However, yeah. We want to use everything that we do, every part of science. We want to like figure out the unknowns, understand that there are things that we don't know, understand that that's exciting, understand that every unknown is something that we can struggle to collectively to understand in order to use it to serve our people. And yeah, if you want to see, I see us having like stem cell labs in the future. I see us having like planetary, like not planetariums, what's it called? Observatories,
Yeah,
giant telescopes, and all sorts of crazy stuff. So also, if you didn't know, we're all colonized people. We're all struggling, trying to live under the system. Oh, we got $25 in reparations from
executive matching
two.
again.
Thank you so much. $20 more in reparations. Thank you so much, Airplane. You can pledge, is what I'm trying to say. If you don't get paid till Friday, you don't get paid to the end of the month. You are 100% welcome to pledge. You're also welcome to share. A share is as good as a donate because it's going to bring someone in and maybe they'll donate. So yeah, donates, pledges, shares, we take it all.
Yeah, exactly. Share. Just like Federico says, every Tuesday, share. So let's share.
And
This
get a
talk
hashtag
right now.
shared if you shared.
Yes, please. Just like drop it. Maybe, I don't know, drop kick it. Just throw it. Like you just yeet it into the comments. Hashtag shared if you've shared. I better see people that have shared because then Little be sad. I'm not going to do that. I'm not going to manipulate y'all. But yeah, please share. Totally.
Oh, not gaslighting the viewers. Chief Felix, can you talk about a little bit about the projects that the funds will be going directly to?
Oh yeah, absolutely. So we already talked about it a little earlier. The water project got started because we lost one of our comrades, actually, chief eyes to this water contradiction that some of our comrades were experiencing. And they did some research of themselves because all colonized people are brilliant and found out that it was the water that was the problem and immediately got to work, made these water filters in just like a few months. And like Chief So was saying, you know, a lot of us, do we know a whole bunch about filtering water? You know, yeah, we can definitely learn about it. Thank you all these people for sharing. I see in the comments. But we want to do it because we know this is a contradiction that is affecting colonized people everywhere. And we know we are true scientists. We know it's something that we can figure out. So all of this money, yes, and share in every dimension so that we can also get water filters to people that exist in every single dimension. In our parallel universe dimensions, we're probably making water filters right now, trying to hand them out to people. Because like I said, it's not only this water, but it's even these contradictions that science can solve, that the colony is unwilling to solve, because the colony isn't going to use science for us. But we are here at Black Hammer, and that's what your money is doing. So thank you so much, Comrade Free. I'm seeing another $10. Appreciate it so much. Seeing hashtag shared. Thank you, Comrade Executive. But yeah, every single dollar helps. Like Chief So was saying, you know, $1, 50 cents, anything that you can do. And then pledging as well. You know, Friday is coming up. I know I get paid this Friday, so I will donate a little bit. But make sure that you still pledge, because there is nowhere on the colony where you can donate where it's only colonized people giving things to only other colonized people. We know it works. We know also the colony gives us things that are broken. It don't even work. We're testing it. We know it's correct. We know going to do what it needs to do, and it'll help all of us stay alive to fight for this revolution. So I want to see a few more donations coming in to hit our $350 goal.
Don't want to see the cat? Want the cat? Nope, not unless they donate.
Oh, okay. We're doing the whole negative reinforcement thing, or like punishment reward.
$5 if you want to see the cat. I don't know what to tell you.
You know, $5 cat loan.
You're worth more than that.
Once we see a donation, you can see the cat. This is not a cat. It's a black hole.
Actually, yeah, you just messed it up because by observing it, you changed it into a cat. It's actually like not a cat at all.
I mean, right now you know her position, but you don't know where she's going. We're all uncertain right now. And with this uncertainty principle, you're going to have to donate because what we're speaking is truth.
That's true. Also, you can match people's donation. That's always a fun, the cat bee. Exactly, Comrade Rohan. And donate for the cat.
Hashtag donate for cat.
$5 more. Thank you so much, Tifa T. All right, watch her not cooperate now. Oh, Lord. There she is.
The colonized kitty. Kitty
Okay,
nice.
She wants to go. She wants to go down.
She's kitty nice. Okay.
All right. Anyone want to match that $5 from Tifa T? I can actually match that $5 in a pledge on tomorrow. I get paid tomorrow, so I'm gonna match that $5. And where y'all at? Y'all don't want to match my $5?
I mean, hey, we could totally turn this into like one of those auctions that we want to. We got $5. Anyone match the cheap side? Can anyone go higher than the cheap side? Anyone go higher than the cheap side with $5? Do I have 10? Do I see 10? Do I see 10? Do I see 7? Do I see 7?
I don't think they could do it.
Probably not.
That's the most money ever in the world. It's clearly too. No, I'm just kidding. The cat.
This cat ain't free. It's really not. In fact, she disappeared. Like,
well, Jenny is a petty boo sellout. She won't join Black Hammer for anything.
I thought we overturned that.
No.
Like I told you, how can string theory be applied to a cat? It's a great question. Jenny, get in here. All right. Well, so how can string theory be applied to a cat? Well, how are we seeing this cat right now? Well, first of all, this cat could exist in multiple different dimensions. And also, just the way that we're viewing the cat right now. Just view anything right now. So you think you know the particles that make up said cats. This cat is made up of strings. That's what all the fur is. Okay. She is afraid not. No. But yeah. String theory can really be applied to anything. Like we said, it's just like a new way of seeing the world and a new way of thinking of things the way that we had, in a different way than we had thought before. Instead of seeing things as just tiny particles and specks of atoms, they're strings. And so, like, this cat is probably made up of a bunch of strings. And in a different dimension, because those strings lead to another dimension, maybe she's like a speckled cat. Maybe she's like a short hair. Maybe she's Siamese. Who knows?
Maybe she's not even a cat.
She's probably a turtle. I really hope she's a turtle because I'm going to that other dimension.
All right, I'm trying to go to a dimension in which y'all are donating for the liberation of y'all people. So where's that dimension at? Let's make that this dimension.
If y'all donated in another dimension, can you like maybe open up your Cash App and just transfer that? Like the way your bank account is set up, you got a checking and savings in one dimension and then the other. So you just move it from one dimension to this one. And then, yeah, we can totally get that.
I want to talk a little bit about what $5 can do since we're talking about $5. $5 can buy, I think we got that entire thing of push to connects for under $5, I'm pretty sure.
Oh, yeah.
So the thing that connects, if you can see in this picture here, sort of down there, the piece that connects the tubing of the filtration system to the container, you can get about, what was it, like 40 of those for under $5. So you could buy a part for 40 reverse osmosis water filtration systems for 40 colonized families to save 40 groups of lives from the poison water that the colony pushes on us for under $5. I'm not trying to save 40 families' lives.
And I mean, yeah, that is definitely a lot that you can do. Like your money definitely goes places. It goes places. Like you'll see that $5 bill and it's just traveling from one way to, like, you see it being given to someone or like being transferred through Cash App or something. And then you see it being paid for these push to connects. Then you follow the push connects in their lives. And now we're building up these water filters. Yes. Oh my God. Yes. Now we have 40 more push to connects.
Thank you so much, Comrade Suski. Oh, TPT's going hard AF.
$5 to ensure 40 lives. It really is a no-brainer. Like, seriously, any dimension could do this. Any dimension. It doesn't have to be this one. So, yeah, for sure. $5, ensuring those 40 lives.
$5, I'm also pretty sure, could cover Some of the VPNs are pretty cheap. Some of them only require like $5 a month or so. Our IT team is quite clearly for the, you know, the type of work that they're in. They want those VPNs. You can get $5 and then get it given back to you in your Comrade, having a secure line to do all the dope IT stuff that we do within our information technology committee. That's the big one. What else can $5? What are you thinking, Chief Felix?
Oh, I'm kind of like, what can't $5 do? Like you were saying earlier, we're scientists. I mean, we can make that $5 stretch.
Exactly. Look at it, tumble. We got that brilliant. We can totally work with something.
But yeah, it can do so much more, especially when you're giving it to us here at SciTech. It's for the parts, it's for our Code Academy. Like Comrade Rohan was saying, the colony doesn't even let us like pursue these things. So all of these dollars is helping us like pursue the things that are, you know, what we've always been able to pursue and be better than the colony ever is at it, because we're simply better than them. And we can only be better than them with a little bit of money, some of y'all's money, some donations, some sharing, so that we can get this out to the masses. This is really important. People need to know about this. We need to give them out to more people. When we do that, we can propagate all of that stuff. So yeah, I want to see a few more donations coming in. Me and IT, we
oh man, true, so true. Oh shoot, that's right. Even fatigue. Yeah, that's what we were talking about earlier. Yeah, because we were doing the ha ha ha, and yeah, and then it combined with that, we had the ha ha ha, but then we ran to the contradiction where we sort of like ha ha ha. But yeah, you know, y'all get that, right? Yeah. So yeah, that's why we need them $5, them more dollars, so that we can continue to do our ha ha ha. And, you know, we can just get this going.
If y'all are excited for this Code Academy, I want to see those donations. You know, you got to pay thousands of dollars to go to Code Academies, like in their system. We're giving this first to the organization and then the masses of the people for 100% free. You can't do that. That's wild. 100% free Coding Academy. I don't think I've ever heard of that, actually, now that I'm thinking about it, like ever in any context at all.
You get a little, like on the original Code Academy, like you can do some things you can do for free, but it's outdated. Like you don't get the current in the know knowledge that you would if you didn't pay like $15 or some like absurd price. So yeah, that $5 will go to that any amount, and still, yeah, you can pledge. It is a-okay just to pledge. If you're not able to donate tonight, that's fine, because we're all poor working class people. And so yeah, sometimes we just don't have the funds on us at the moment. There's absolutely no shame in that. You can totally pledge. The only downside is that we got to follow up.
$15 in reparations. Thank you so much. And some of y'all are not poor working class colonized people who are not struggling. So I want to see those reparations, y'all. Thank you so much. We actually, with those 2 reparations, we got a $12 more towards our goal. Who wants to be the one that takes us to our goal?
We are very close. We are getting pretty close to our goal.
We got $12
right
left.
We really do. Who can?
I want to see $12. And I want to see, I feel like there's some overachievers that might do 13 just to really take us there.
I saw someone do it in pounds one time. We can do this in pounds or LBs. I don't know. If we can just do this.
LBs, land backs.
Yes. You can donate land backs, but you have to convert them to cash first. And that costs $5 to do that. So just donate the $5 to us and we can convert those.
We need $12 more to hit this goal. You know what? I'm not doing the rest of the show unless y'all do $12 more. I will leave right now.
And yeah, that's the thing. So
Bye.
We had their position. But now the only thing that's uncertain is we don't know where they went. That really shows, again, with this uncertainty principle. In fact, I know where I am right now, but where am I going to go? I don't know. In fact, I'm not going to do that. I'm not going to walk on camera. You just have everyone just quits all of a sudden. Okay. I would have appreciated a warning.
Oh, my bad.
$3. Thank you. 13 euros.
We hit the goal.
$15.35. I think we just did this. Oh, okay. Yes. $10 more.
We smashed the goal.
Thank you.
Over the goal.
With that colonized tea. Thank you.
Land back to Dio.
Oh,
there we go.
Yes, thank you to Dio.
Salute to each and every one of y'all. We know that it's not easy to survive on the colony. I know that a lot of this, no shade, sometimes it's the last amount of money you got. I've donated the last $5 I had to name a city before. We know that $5 for a colonized person means you really believe in the future we're building. because it's not an easy thing to give up $5 on the colony. Like sometimes that's the difference between if you get to eat or not.
Oh yeah, it can be like a life or death thing. And yeah, it is the thing that we were talking about earlier when we mentioned the whole you do science every day. Like when you're trying to figure out how to use this $5, whether it be to eat or whether it be to benefit yourself in some other way. That is science right there. You are doing science within making that conscious decision. And also my favorite thing to do, how we got string theory was someone just decided to ask why, or someone decided to ask, and then what? And so if you are the type of person that can ask why or can ask, and then what, then congratulations, you belong in science tech because you are a scientist, my friend. You have asked the two main questions that science is always asking. Why and then what? That's always what I'm thinking. I'm always doing science. I'm doing science right now. You just can't see it.
My parents hated that because that's all I ever said. Why? You have to go to bed now. Why? Because it's time. Why? Because
I
you
said
need enough
so.
rest. Why?
Because I said so. Why? Oh, the worst thing. The worst because I said so. Don't even get me. I can't. It's uncertain where I'll go with this topic.
All these decisions in your head are just, it felt statements. Also, y'all are all coders. Chief T always says, if you can go into your phone and change your settings on your phone, you're a coder. And, you know, I didn't really get that until I started like learning some of the Python stuff that we're doing for our coding academy. And I was like, a lot of this, it just makes sense. A lot of it is almost just like the way you think, just written down into code, which is interesting. We definitely need to do an episode on AI one of these days.
Oh, I think we will. But I don't know how real that colonized brilliance will be because it's artificial. We got artificial brilliance right here. Hashtag artificial brilliance. This is just a sneak peek for our next one.
All right. Well, salute y'all again. Thank you so much for donating. Again, we understand what like $5 is to a colonized person. We take it seriously. We take it super seriously in MySpace. That's how I knew how to code is MySpace. I had to have my ish set up nice. Like I wasn't playing around with y'all like in Neopets because I'm like old. I had Neopets and it used to be that you could change your Neopets profile with these. But anyways, y'all, salute so much. Thank you so much for your donations. Thank you so much for tuning in. This again is critical mass, understanding that we are the masses critical to the revolution, and critical mass will play on words, double entendre, smallest amount of mass necessary to sustain a nuclear fission. This is not our only show, far from it. We have shows, I think, basically almost every day of the week. We definitely have workout self-defense classes every day of the week. So just some announcements for y'all. Friday, July 16th, aka tomorrow, 8 p.m. Eastern time. Same time as this, we have hard targets where our comments from Black Hammer Time break it all the way down, current news events, and I'm sure they will be talking probably about defending the Cuban Revolution this week. And they have a bunch of topics every week. They really break it down and hold no punches and really like combating the colonial and imperialist and white power capital colonial hordes of the world, and also showing off colonized brilliance too. So it's a new show. You don't want to miss it because you're not going to see news like that anywhere else. Then on Sunday, the morning of the 11th at 8 a.m. Eastern Daylight Time, we have the Revolutionary Book Trap with our brilliant Sergeant Bayer and our brilliant Chief Oju. Bury My Heart at Wounded Knee. We're going to be studying the revolutionary struggle, the anti-colonial struggle of the indigenous people of Turtle Island. Really taking the lessons from that and understanding our duty as anti-colonial revolutionaries as the progression of the struggle and honoring our ancestors and learning from them. And so that's going to be super dope. This is mandatory. If you're in Black Hammer, you better be there. It's mandatory. Bring your read that bags. We're going to delve into it as a collective and really they always have some gems. Oju and Bear are absolutely brilliant. Then Monday, July 19th, every Monday, but this Monday too at 8 p.m. Eastern Daylight Time, we have the Oh My Ghazi show where Ghazi and the crew break down like literally everything under the sun. It's exciting because I never know what they're going to talk about. They talk about like celebrity tea, current events. They talk about music. They talk about literally everything under the sun. It's super exciting. It's all with the anti-colonial analysis. You can also email your questions. If you want to hear them talk about a specific thing, you can email the topic you want to talk to. It's askohmyghazi@gmail.com.
I already got some ideas of what I want to ask.
I wonder what I want to ask. I don't know. I guess I'll figure it out.
It's uncertain.
It's uncertain. All right. Tuesday. Y'all know the deal. July 20th, 7 p.m. Eastern, the most important day. It's so funny. I feel like for Hammers, the week like restarts on Tuesday and not Monday because of the rally. We have a very important rally. Revolution is bubbling as the empire is crumbling. We are building, they are falling. The new world we're literally on the cusp of it. We can feel it every day in the power that we're building for our people, and they are falling the F apart. It's beautiful to watch. So come together. Political education. We have speeches from our Secretary General, our Commander in Chief, updates from all our committees, SciTech included. This is also mandatory if you're a member, and you should be inviting your friends, your family, co-workers, entanglements, Tinder dates, pets, anything, anyone you know that is colonized. All animals are colonized. And bring them into the rally. 7 p.m. Eastern, Tuesday. Yeah. Thursday, we have another episode of Critical Mass. We'll be back. Same time, same place. We will have another guest, so keep out your eye out for the graphic. We'll also have another topic. Same deal as we've had these past two, just breaking down science to the masses in an anti-colonial lens. And then Sunday, the last Sunday of every month. So not this Sunday, but I think the next. Or is it 2 from now?
Next Sunday.
Forging the Hammer, monthly political study. This is also mandatory. It's put together as an entire organization at 3 p.m. Eastern on Sunday. So make sure you're planning your outreaches around it. As an entire org to do a real deep dive and forge yourselves to our political theory that informs our practice, which will win liberation for the colonized masses of the world.
It was that date, y'all.
Finally, our super dope single, White Power to BMX, coming out of Mad, Music, Acting, and Dance from the Mad Hammers, is on Spotify, Amazon, iTunes, YouTube, SoundCloud, Bandcamp. I don't even know what Lump is. It's on everything, y'all. It's literally on everything. Make sure you're streaming it, really listening to the political message. It's also like a dope song. It's like a hard song. Like the beat is crazy, the bars, the flow. It's a great song up and down. It's also political education. Like I think people forget how powerful of a political education music can be.
For sure.
Yeah, and this is the first single coming out of. So make sure you uphold that fourth principle of unity, the brilliant colonized leadership of our music, acting, and dance team, as well as MOD Sundiata, who really led this project and has a verse on there as well. Stream it.
You can't avoid it. It's on all of those platforms. Like, what are you going to do?
If you are not a colonized person and you want to be on the right side of history, I'm sure you saw them in our comments. Join our reparations corps. Wash that blood off your hands and participate in the revolution by falling under colonized people's leadership. And if you are a colonized person, beautiful colonized person, leadership of the revolution, join Black Hammer today. Join SciTech today. We're doing incredible science for the people. No experience necessary, no degree necessary, no background necessary. We honestly prefer people without it in a way because they're not so indoctrinated with this petty boo idea of what science is. Absolutely no experience necessary. Go to blackhammer.org/join. If you haven't joined yet, get in the revolution. If you've already joined but you're interested in joining SciTech, email us. Our email down there is bhoscitech@protonmail.com. You don't need those pieces of paper from a white man saying what you can and can't do. We all know that they're a lie. Anyway, join us today. Any of the projects we have, we would love to have you on. Bring your own ideas too. Like we have a 3D printer. We have a 3D printer now.
Oh, yeah.
There's so much stuff we could be doing. We want to hear your ideas. We want to know, what the masses, where do they see a need that we could fill for the people? Where do they see a way that we could show the people their own leadership and their own power? We want your ideas, too. Come on into SciTech. Email us. Join Black Hammer today. And let's get it.
Oh, yeah, for sure. For sure. I'm super excited. And I really hope you guys do totally join. I'd be super excited to see the new people in there. Kind of. I'll be worried at first because humans scare me. But then, once you guys actually start getting into it, oh, yeah, for sure. Then you'll like me. Then you'll get used to my really bad jokes.
Yes, absolutely. And I want to thank our incredible human, Comrade Rohan, for joining us today for our show. You did a great job. It was so much fun having you as a host, learning about string theory with you. I had so much fun. Hopefully y'all enjoyed having her on too, because I know I had a really good time. And also everyone who is joining us today, participating in the comments. You make this so much more exciting because we're doing it for all of y'all, you know, trying to get science out to the masses. We want to break it down for y'all because it really isn't that hard. Like Comrade Rohan introduced it in the beginning. People say it's really hard and they don't let you study it, and it's really not that bad. So I hope everyone had a good time. I always have a great time doing this show. All right, so I think with that, unless anyone doesn't have anything else to say, we can close it out with the land back.
Land back.
Land back.
Land back.